Calorimetry podcast. Learning target for today is in a calorimetry experiment. Use the equation Q equals mc delta T to find the heat absorbed by the water, then find the combustion per gram of fuel.
Just a reminder, for this and other podcasts, the specific heat of water, C, will always be 4.18 joules per gram degree Celsius. Remember, in these particular problems, we will be warming water by burning something. And don't forget, for Q equals mc delta T, Q is the heat gained or lost. M is the mass of the material that changes temperature, and that is usually, but not always, water. C, of course, is the specific heat of the substance that changes temperature, and for us that's usually water, and delta T is the change in temperature.
All right, so for those that are a little confused, Mr. Havlis and I are doing this podcast together, so if you hear different voices, that's what's going on. First example we're going to do is example number 1 here. A 1.5 gram cashew was burned. The heat from the burning raised the temperature of 150 grams of water from 21.2 degrees Celsius to 48.7 degrees Celsius. Key thing here, if you want to notice, this is going to be 3 sig figs. Notice the decimal point right there. 2 questions we're going to ask here. How much heat was released when the cashew burned, which you'll see in the next slide. And then B, what is the heat of combustion per gram of cashew, which you'll see in the slide after that. All right. Let's see what we got here. Using the equation Q equals the mass of the water, all right, 150 grams of water, times our specific heat, which is always going to be the same. All right, notice it's joules by grams degrees Celsius, so I'm going to show you how everything cancels here in a sec. All right, you're going to multiply that by 17.5 degrees Celsius, and if you look back for a sec here, we got this by subtracting 14.87 from 21.2 to get that change in temperature. If you notice here, you end up getting joules when you multiply all these things together. This happens because of cancellation of units. For example, the grams here of this water cancels with this grams right here. Right? The degrees Celsius cancels right here as well, so all you're left with then is joules, which when you multiply this all together, you get 10,973 joules. All right? We do use sig figs like we should be using sig figs here. So because this was you're given with 150 point, you need to have 3 significant figures in your answer. And here you have right here, 1.10 times 10 to the 4th. And that should be your correct answer. Next problem, again with B. All right, what is the heat of combustion per gram of cashew? All right, all we did is we took the answer from the last problem, which again, if you flash back here for a sec, this was the answer to our last problem. Divided that by 1.5 grams. And you're probably asking, okay, where do we get the 1.5 grams from? If you go back to the beginning problem here, you notice you're dealing with a 1.5 gram cashew. The biggest problem a lot of people are going to have is they're going to use the wrong given. This for grams of water to deal with the heat being released. This is for the grams of cashew. All right, forward ahead again, back to the problem. If you notice, you take the water divided by the grams here of the cashew, divided, you get 7,300 joules per gram, which is nice because this has 2 sig figs, which again, our answer has 2 sig figs right here.
Let's do one more example. A 2.1 gram sample of popcorn was burned. The heat released raised the temperature of 1.25 grams of water from 23.1 degrees Celsius to 51.2 degrees Celsius. Again, we're burning the popcorn, we're heating the water, we're finding out how much heat goes into the water. So we'll take our Q equals mc delta T equation and we'll substitute. We have 125 grams of water. This is C, this is the specific heat of water, 4.18 joules per gram degree Celsius. And this is the change in temperature of the water. We got this value from subtracting 23.1 degrees Celsius, the starting temperature of water, from 51.2 degrees Celsius, the ending temperature of the water. When we do this on our calculators, we get 14682 joules. The problem with that is that we don't have the correct number of sig figs. 125 has 3 sig figs, 4.18 has 3 sig figs, 28.1 has 3 sig figs. We need 3 sig figs in our answer. Since this next digit over here is an 8, we're going to round this off to 14,700 joules. Now remember, this is the amount of heat that was given off by burning a 2.1 gram sample of popcorn. We usually want to express this per gram of popcorn, so that's what we'll do in our next slide. We'll take our value, 14,700 joules. We'll divide it by the number of grams of popcorn, 2.1 grams of popcorn, and we get 7,000 joules per gram of popcorn on our calculator. The problem with this is that this has 3 sig figs, this has 2. We need 2 sig figs in our answer. So we have to take this number, 7,000, and we have to write it in scientific notation, 7.0 times 10 to the 3 joules per gram, to give us the value in joules per gram. We could, if we want to, compare the energy released from our popcorn per gram to our energy released per gram of cashew, and we could compare energy values that way because they're each given as per gram.
And that's pretty much it. So hope you guys enjoyed the podcast. A little duo action here. You guys should then work on your practice worksheet and have that checked out.